The National Electrical Code does not specify a minimum height requirement for electrical panels. However, the NEC does require a minimum working space in front of the panel for safe operation and maintenance. NEC Section 110.26 states working space around electric equipment shall be adequate to permit ready and safe operation and maintenance of such equipment. The NEC does not prohibit the installation of electrical panels in bedrooms. However, it does provide specific guidelines for the location and installation of panels in habitable rooms. NEC Section 404.8 A1 states in living units, electrical panels shall be installed in an accessible location, but where the panel would be exposed to physical damage, it shall be guarded. AFCI, or arc fault circuit interrupter breakers, are designed to detect and interrupt dangerous electrical arcs that can lead to electrical fires. When an AFCI breaker trips, it can be inconvenient, but it is essential for safety. Installing an electrical panel in a bedroom with AFCI breakers requires careful consideration to ensure that the panel is readily accessible for any necessary maintenance or troubleshooting. If possible, it is recommended to relocate the electrical panel to a more central and accessible location. This will improve the safety and convenience of the panel. If installing the panel in a bedroom is unavoidable, consider the following recommendations. Firstly, choose a location that is not directly adjacent to the bed or other furniture. Secondly, ensure that the panel is at least 30 inches from the floor to allow for easy access. Thirdly, consider installing a lockable cover or guard to prevent unauthorized access. And fourthly, inform the homeowner about the importance of AFCI breakers and the need for prompt attention if they trip. Section 110.26 addresses the space about electrical equipment operating at 600 volts, nominal or less to ground. It's crucial to provide sufficient and readily accessible working space for safety. The depth of the working space and the direction of access to live parts must not be less than specified in Table 110.26. A1. Distances are measured from the exposed live parts or from the enclosure if the live parts are enclosed. The required distances depend on the voltage to ground and the condition. Condition 1 applies where there are exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space, or where there are exposed live parts on both sides of the working space that are effectively protected by insulation or other means. Condition 2 applies where there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 applies where there are exposed live parts on both sides of the working space and the conditions are not as described in Condition 1 or Condition 2. Concrete, brick, or tile walls are considered as grounded. Access and entrance to working space must be provided to give access to the working space about electrical equipment. At least one entrance of sufficient area must be provided to give access to the working space. For equipment rated 1200 amps or more and over 6 feet wide that contains overcurrent devices, there must be an entrance at each end of the working space. Where the location permits a continuous and unobstructed way of exit travel, the two entrances are not required to be located at opposite ends of the working space. The minimum height of working space is 6.5 feet measured from the grade floor or platform. The working space must be clear and extend from the grade floor or platform for the entire height and depth required by this section. Equipment like raceways and cables is allowed within the space if properly protected. The width of the working space in front of the electrical equipment must be the width of the equipment or 30 inches, whichever is greater. In all cases, the working space allows at least a 90-degree opening of equipment doors or hinged panels. Regarding dedicated equipment space for service equipment, switchboards, power boards, and motor control centers, the space equal to the width and depth of the equipment and extending from the floor to a height of 6 feet above the equipment or to the structural ceiling, whichever is lower, must be dedicated to the electrical installation. No piping, ducts, or other equipment foreign to the electrical installation can be located in this zone. In dwelling units, suspended ceilings with removable panels are allowed in this zone. Equipment that is associated with the electrical installation and is located above or below the electrical equipment is allowed in this dedicated equipment space. For indoor electrical equipment, a dedicated space is required above the equipment. This space must extend to the structural ceiling or 25 feet above the floor, whichever is lower, and must be kept clear of foreign systems unless protection is provided to avoid damage from condensation, leaks, or breaks in such foreign systems. These requirements ensure that electrical equipment is installed and maintained safely, with sufficient space for workers to access and perform their tasks without obstruction. Considering Section 404.8 regarding location of switches. All switches and circuit breakers used as switches must be located so they can be operated from a readily accessible place. They must be installed so that the center of the grip of the operating handle, when in its highest position, is not more than 6 feet 7 inches above the floor or working platform, unless specific exceptions apply. In unfinished basements that are only used for storage, switches are allowed to be mounted at the top of a stairway. This exception acknowledges the limited use of such spaces and the need for a convenient switch location. In industrial establishments and commercial buildings, accessible listed busway plug-in switches are allowed to be located at the same level as the busway. This acknowledges the specific needs of industrial and commercial settings. Switches installed adjacent to a stairway to control lighting for dwelling units are required to be located where the stairway enters the dwelling unit. This ensures convenient lighting control at the point of entry. In regard to switch faceplate requirements, faceplates for switches, receptacles, and similar devices must be installed to cover the wall opening and seat against the wall surface. This ensures a neat and safe installation. Faceplates must be made of insulating material unless they are constructed of metal and the box or support is installed so it is effectively grounded. Metal faceplates must be grounded to reduce the risk of electrical shock. Surface-mounted switch or receptacle boxes used in uncombustible walls must be installed so that the front edge of the box is not set back more than 1/4 of an inch from the finished surface. For combustible walls, the front edge of the box must be flush with or project from the finished surface. These requirements ensure that switch and receptacle boxes are properly installed and aligned with the wall surface. These regulations promote electrical safety and ensure that switches and circuit breakers are easily accessible and safely installed in various settings. Specific rules are provided for damp or wet locations. In damp or wet locations, surface-mounted enclosures for switches or circuit breakers must be weatherproof. This prevents moisture from entering the enclosure and causing damage or creating a safety hazard. Flush-mounted enclosures in damp or wet locations must be made weatherproof when used without a weatherproof cover. This ensures that the enclosure is protected from moisture even when the cover is removed. Switches or circuit breakers installed in wet locations must be installed in an enclosure that is weatherproof whether or not the enclosure is required to be weatherproof. This provides an additional layer of protection in environments where exposure to water is likely. Switch or circuit breaker enclosures in wet locations must be mounted to prevent moisture from entering or accumulating in the enclosure. This helps to prevent corrosion and electrical problems. The NEC addresses the installation and use of arc fault circuit interrupters, known as AFCIs, which are designed to protect against electrical fires caused by arc faults. Dwelling units require AFCI protection for all 120 volt or 240 volt branch circuits that supply outlets installed in various areas. These areas include kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, and similar rooms or areas. This comprehensive list ensures that most areas in a home are protected against arc faults. The NEC provides an exception to the general requirement for AFCI protection. AFCI protection is not required for a branch circuit that supplies only one receptacle for a specific appliance or piece of equipment. This exception applies only when the receptacle is readily accessible and the appliance or equipment is unlikely to cause an arc fault. The NEC recognizes two types of AFCIs: branch or combination AFCIs and outlet branch circuit AFCIs. Branch or combination AFCIs provide protection for the entire branch circuit, including the wiring and any outlets connected to it. Outlet branch circuit AFCIs provide protection only for the outlets and the branch circuit that are downstream from the AFCI. To provide AFCI protection, one of several methods can be used. Firstly, install a listed branch or combination AFCI at the origin of the branch circuit. Secondly, install a listed outlet branch circuit AFCI at the first outlet on the branch circuit, combined with a listed surge protective device. Thirdly, use a listed outlet branch circuit AFCI at the first outlet on the branch circuit without a surge protective device, but only if specific conditions are met. The conditions for using an outlet branch circuit AFCI without a surge protective device include the branch circuit wiring being installed in a metal raceway, metal wireway, metal auxiliary gutter, or using metal sheath cables. The metal raceway, wireway, gutter, or cable must be connected to a metal outlet or device box. The outlet box must be connected to a grounding electrode conductor. The combination of these measures ensures that the branch circuit is effectively protected against arc faults. When an AFCI trips, it is important to determine the cause of the trip before resetting the breaker. Arc faults can be caused by damaged wiring, loose connections, or faulty appliances. If the cause of the trip is not addressed, the AFCI may continue to trip or a fire could result. Electrical panels in habitable rooms must be installed in an accessible location. If the panel would be exposed to physical damage, it must be guarded. The location should also allow sufficient space for safe operation and maintenance, as specified in Section 110.26. The best approach is to find a location that meets these requirements and minimizes inconvenience. If the panel is installed in a bedroom, ensure it does not obstruct access or create a safety hazard. Informing the homeowner about the importance of AFCI breakers and the need for prompt attention if they trip is a critical safety measure. AFCI breakers are designed to protect against electrical fires, and their proper functioning is essential for safety. Ensure that the homeowner understands how AFCIs work and what to do if one trips. Provide guidance on troubleshooting common causes of AFCI trips and recommend consulting a qualified electrician if the problem persists. It's important to consider voltage drop. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and equipment to malfunction. To minimize voltage drop, use conductors of adequate size and keep circuit lengths as short as possible. NEC Section 210.19. A4 provides guidelines for voltage drop in branch circuits, recommending that the voltage drop should not exceed 3% for branch circuits and 5% for feeders plus branch circuits. When installing a subpanel, consider the ampacity of the feeder conductors. The feeder conductors must be sized to carry the calculated load of the subpanel. Use NEC tables, such as Table 310.15. V16 to determine the ampacity of conductors based on their size and insulation type. Ensure that the conductors are protected by an overcurrent device with a rating no higher than the ampacity of the conductors. Additionally, consider the grounding and bonding requirements for the subpanel. The subpanel must be properly grounded to provide a low impedance path for fault current to return to the source. Connect the subpanel to the grounding electrode system with the grounding electrode conductor size according to NEC Table 250.66. Bond all metal parts of the subpanel enclosure together to create an effective ground fault current path. When routing conductors through walls or floors, protect them from physical damage. Use conduit or other approved methods to protect the conductors. Ensure that the conductors are properly supported and secured. When making connections, use approved connectors and terminals. Tighten all connections to the manufacturer's specifications. Proper connections are essential for preventing overheating and electrical faults. After completing the installation, test the subpanel to ensure that it is functioning properly. Use a voltmeter to verify that the voltage at the subpanel is within the acceptable range. Use an ammeter to measure the current flowing through each circuit. Use a ground impedance tester to verify that the grounding system is functioning properly. Document the installation with clear and accurate records. Include a wiring diagram showing the layout of the subpanel and the circuit it serves. List the size and type of conductors used for each circuit. Note the ratings of the overcurrent devices protecting each circuit. Keep these records in a safe place for future reference.